whatever. All right, so we've got 23 people here. Where's everybody else? Well, glad to have everybody here. So today we're going to be covering section 1.2. Oh, and by the way, I forgot to post the lecture notes yesterday, but I did post them today. So anyway, here's what we're going to talk about. So these sections are pretty short. We're probably going to cover 3 sections today. And so this will be kind of fun. So, all right, so we're going to talk about observational studies versus experiments. But before we do that, we're going to talk about a census, okay? And the idea behind a census is we attempt to include the entire population in a sample. So this is usually the best, but it's very often not very practical. You know, it would be nice, well, maybe it would be nice if you think about it. Once again, we're in election season. It would be nice if the pollsters could ask everybody, you know, who are you going to vote for, Joe Biden or Donald Trump? But obviously, well, we'd probably get sick of that question after a while. And so they don't ask everybody. Usually they rely on a sample. So let me ask you another question. If you were going to test a light bulb to see how long it lasts, would a census be a good idea?
No.
Oh, because?
Well, there's a lot of variables in it. Like, I don't know how you'd even test how long a light bulb would last with the entire population.
Okay, anybody else got any ideas on that? There's only one variable, how long it lasts, actually.
You'd use them up. There wouldn't be any light bulbs left.
Yeah, you wouldn't be able to sell any if you tested it until it burned out, right? There would be no reason to sell any, because who wants to buy a used light bulb?
Plus, I feel like if you're making like the same light bulb, you wouldn't need to test every single one. You would want to test a sample from like different manufacturing plants, things like that.
Well, yeah. So if you worked for, let's say, General Electric, it wouldn't make sense to test every single bulb because you wouldn't be able to sell any, because they'd all be burned out. So, yeah, you just test a few of them. So, so a lot of times samples are better than a census. Okay, so we're going to talk about 2 different types of studies. One's called an observational study. The other is called an experiment. So just like it sounds, an observational study is where you observe and measure the responses, but you don't attempt to influence. So sometimes this is the only way to conduct studies due to ethical reasons. So I'll give you an example. There was a Danish study that kept track of 420,000 Danish cell phone users between 1982 and 1995. They compared the rate of brain tumors in people without cell phones and found there was no difference between the groups. So this would be an example of an observational study. We're not forcing people to use cell phones, or we're not taking away their cell phones. We're just observing and measuring. And so this would be an example of what we would call an observational study, okay? So it's important to say you don't attempt to influence. With an experiment, on the other hand, you deliberately impose some sort of a treatment on the individuals in order to observe a response. So an example of an experiment was, okay, we've got a group of rats. We're going to divide the rats into 3 different groups. The first group receives analog cell phone radiation 4 hours per day, 5 days a week, and we go for 2 years. It's supposed to say for 2 years. The second group receives digital cell phone radiation for the same period. The last group, which is what we would call the placebo group, would receive no radiation. And so the cancer rates were compared. One's analog, one's digital, one's none. And there was no link found. So the idea here is, with an experiment, we forced the rats to have cell phone radiation. One was analog, one was digital. and one was none. And then this would be an example of an experiment because we deliberately imposed a treatment on the individuals. And in this case, the individuals are rats. Okay? Now, generally, experiments are preferred, but it's not always ethical. So would it be ethical for me to force half of the room to smoke and determine if it causes lung cancer? Okay. A lot of you wouldn't like to smoke, right? Now, sometimes we have smokers and they'll be like, I'll be in the smoking group, but so yeah, it wouldn't be ethical for me to force half the room to smoke, but experiments would be preferred. And so anyway, so that's a lot. A lot of times we do observational studies because we can't force people to do things. Now, let me talk about a study that was done in the 1970s, and it stated that sugar caused heart disease. So first question is, oops, I didn't mean to erase that. Has anybody ever heard of that? This, yeah. Later studies done that was shown that there was no link between sugar and heart disease. The original study was flawed because of confounding. So confounding is going to be an important word you're going to want to know. The idea with confounding is it's the effect of two or more variables are not separated. So let me tell you a little bit about this study. So what happened was the original study did not tell if people were smokers. So you've got 9 people here that I can see your answers. So I guess you guys will be my little convenient sample here. Did you guys know that smokers consume more sugar than non-smokers?
Okay. I feel like I know that.
Broderick, you knew that? How did you know that?
Well, I've heard it and I've seen it like with family personally. Just it tends to be people who are smokers. Smokers tend to keep their hands busy and they generally eat candy more. I don't necessarily know it's across the board. It's just what I've seen.
Okay. So it's kind of interesting. The study, I think, was done in the 1970s. And so I don't know if we have any coffee drinkers here, but Starbucks did not exist in the 1970s. And so generally in the 1970s, if you wanted your coffee, you had to put your own sugar in. And so one of the interesting things that people didn't know was that a lot of times when people smoke, they drink coffee, and when you smoke, you can't taste as well because it kind of kills your taste buds. And so people would just pour tons of sugar in their coffee because they couldn't taste it unless there was a lot in there. And so what happened was they because they didn't the original study didn't take into account smoking, and surprisingly, smokers consume a lot more sugar in their coffee. And so when smoking was taken into consideration, the effects of sugar vanish in relation to heart disease. And so the real cause of the heart disease was smoking. It was not sugar. And so in this case, smoking is what we would call a lurking variable. So my favorite definition of a lurking variable is what you forgot to include in your study. Okay, so in this case, or a better thing would be a lurking variable is a variable that was not considered in the original study. In this case, it was smoking. Smoking wasn't considered, and so smoking was the lurking variable. So lurking variables and confounding always go together. They're always linked. So confounding means 2 or more variables aren't separated. So in this case, sugar was not separated from smoking, and smoking would be considered the lurking variable. So whenever you have confounding, you have lurking variables present. Okay. So that's one of the issues with observational studies. is a lot of times they're more subject to confounding, and that's why scientists generally prefer experiments, because you can control experiments a lot better. But a lot of times you can't force people to do experiments for ethical reasons. And so I can't force people to smoke. I can't force people to go to church. I can't force people to have abortions, to see if it affects the health of the mother. And so a lot of times we have to rely on observational studies. So there are three main types of observational studies. We have cross-sectional studies, we have case control studies, and we have cohort studies. So cross-sectional studies, the idea with cross-sectional study is you're going to collect information over a short period of time. So for example, maybe we'll compare the incidence of lung cancer between smokers and non-smokers. The idea is you're doing it over a short period of time, a day, a week, a month, maybe a year. You could even do it over a year, but it's a relatively short period of time. The problem is, let's say that I wanted to do a cross-sectional study on our class. So let's say that I wanted to say, how many of you have cancer? And I hope that nobody would raise their hand. And so, if I did a cross-sectional study today, nobody raises their hand, I'm happy that nobody has cancer. Tomorrow you go to the doctor and you find out you have cancer. So the problem with a cross-sectional study is, because you're collecting it over a short period of time, you're going to miss. So maybe you have cancer today, you just didn't know about it. And so when I did my survey, I missed out on the cancer that you had. So that's an example of a cross-sectional study. Now let's talk about a case control study. Case control studies are retrospective. Retrospective means we're going to look back in time. And so with a case control study, we're going to look back in time and we're going to look for different characteristics. So these are often used in rare cancer studies. The idea is you look for differences between the cases of cancer and the controls. So the idea is you try to match people based on characteristics. Some of the common characteristics are age, income, race, whether they're a smoker, etc. The drawback is people have a poor memory, and sometimes we don't get truthful responses. So for example, if I were going to do a case control study, maybe I would, so some examples would be, let's find out who, like a diet study or a smoking study or a drug study. Well, let's do drug, especially illegal drugs. If I were to say, especially now that we're on camera and you can all record your responses, if I were to ask how many people had done illegal drugs in the past week, you're probably not going to raise your hand even if you had, right? You don't want me to be identified. Plus, this is going on YouTube, and you don't want everybody on YouTube knowing, hey, I used illegal drugs. Okay, so there can be an incentive to not be truthful, especially in a class like this. Or even, let's say it's something more simple. If I were to do a diet study, I wanted to compare the overweight people to the good weight people, or you've got a good weight, and I asked you what you ate. Whether you're overweight or not, you're probably going to tell me that you ate more vegetables than you actually did. And so, or even if I were to ask this, let's just ask this for a simple diet question. How many of you remember what you ate for breakfast last Monday? I usually get one or two people that raise their hand because they eat the same thing for breakfast every day. But yeah, most of you, if I were to ask you to go back and remember what you ate for breakfast, you're probably not going to remember. And so that can be one of the drawbacks with the case control studies. So the idea is you compare the cases versus the controls, and you're looking back in time to see differences. But the drawback is poor memory or truthful responses. Okay. Now, another type of observational study is what we call a cohort study. Now, whereas a case control study is retrospective, a cohort study is what we call prospective. Follow a group over time, okay? And so, so you go forward in time, basically. Some of these studies can last decades. There's a famous study called the Framingham Physicians Study. One of my professors at the University of Utah was part of that. Basically, they enrolled a bunch of people in the 1960s or 70s, I don't remember, in Framingham, Massachusetts, and then they followed them for decades. And so one of the interesting things that he told me was, he said that sometimes they would send you pills in the mail and they'd say, here, take this. And you didn't know if you were getting the drug or the placebo. He said, except for one time, they told him to take a pill. Of course, he didn't know what it was, but he took it and it kind of dissolved in his mouth a little bit before he swallowed it. And he said, that kind of tastes like aspirin. And it was aspirin. And so one of the things that they did with that was one of the studies where they found that people who took aspirin were less likely to have a heart attack than people who did not take aspirin. And so, so that's an example of a cohort study. The problem with cohort studies is they are very expensive because you're doing this over time. But they're also much more accurate. All right, so some people are biased against observational studies, but sometimes they're the only ethical ways to study certain things. And so, anyway, so do you guys have any questions on chapter 1.2, which is experiments and observational studies? Okay. Like I said, that was a nice short chapter. So now we're going to move on to section 1.3, which is on simple random samples. There's a question?
Yeah, I'm just confused. How was that cohort experiment observational? Because weren't they interacting with them?
So I did mix that up a little bit. Generally, with the so that was actually an experiment. You're correct. But generally, they're not influencing them. But yes, you're correct. That was actually an experiment. But generally, with a cohort study, you're following people over time, and you're not attempting to influence them.
Okay.
So, very keen observation. Told us that was an experiment, not an observational study. So, I did mix that up a little bit. But yes, the same rule applies. They shouldn't be influencing them with an observational study. Okay. All right. So, section 1.3, we're going to talk about simple random samples. So a simple random sample is a sample of n individuals. They're chosen so that everyone has an equal chance of being chosen. Let me just tell you that randomization can be difficult. So one of the interesting things is there was a researcher and he was using there's a random number generator in Microsoft Excel. And he discovered that the numbers weren't random. The reason why we do random studies, it would be nice to do a census, but it's costly. And so the idea here is if you do a simple random sample, hopefully your sample can represent the population without talking to the entire population. Okay. Now let's also talk about bias. Bias is another definition we need to know. It's to systematically favor certain outcomes. So often bias is unintentional. Sometimes it is intentional. When I talk about bias in this class, I'm using it in the statistical sense where we're not, it's not like I'm biased against you, I don't like you. The idea here is I'm systematically favoring certain outcomes. So an example, let's say that I were to go to the mall during the day, okay? So who usually goes to the mall in the middle of the day?
Some people.
I would say probably the older retired.
Yeah, retired people, because they don't have a job, right? They can go to the mall during the day. The rest of us are working, okay? Or if I were to go at, say, 4 or 5 o'clock in the afternoon, who's at the mall?
Typically those who just got off work.
Got off work, or a lot of times teenagers. Although this might be a bad example. It used to be that teenagers were the only people that were at the mall, right? So that used to be the place to hang out. Now malls are dying. But so the problem is, if I do a study and if I go to a mall, if I go in the morning, I'm going to get the mall walkers. So they're all going to be retired people. And so I'm going to be systematically favoring old people. And if I go to the mall in the afternoon, it'll be all the kids that have just gotten out of school and are hanging out at the mall. And so therefore, I'm going to get a lot of young people. So even though I don't intend to have bias in my study, I'm going to systematically favor old people, or I might systematically favor teenagers, especially if I go during the middle of the day. All the people who are working are not going to be there, except for, of course, the workers. And so a lot of times bias is unintentional, where you're systematically favoring certain outcomes. So that's what I mean by bias. And so anyway, that'll be the definition. Convenience sample would be easy to reach individuals. So, you could go to the mall and you can ask people who's going to win the football game. The question is this representative? And so typically it's probably not going to be, for the reasons I just mentioned. So mall samples typically overrepresent teens, retired people, the prosperous, and you're going to miss out on the poor because poor people can't go shopping, right? All right, so a voluntary response sample. It's often done on websites and call-in shows. People with strong feelings participate and others don't. So, if Rush Limbaugh has do you support gun control? Do you think that that voluntary response sample is going to be representative of the entire nation?
No.
Probably not. They're probably going to be representative only of Rush, and they may not even be representative. And so the problem is a voluntary response sample is another case where you've got bias, okay? Now, an example of a voluntary response sample, most of you are probably too young to remember Ann Landers. Or have you guys ever heard of Dear Abby? Oh my goodness, you guys are too young. So Ann Landers and Dear Abby were sisters. They used to have an advice column, and Ann Landers conducted a sample, and she said, if you had to do it over again, would you have children? 70% of the people responded no, and she had a huge sample of 10,000 responses. Do you think that that would be representative of all people?
No.
No, probably not. Okay, she probably got all the jaded parents that had horrible kids and were like, yeah, it was a mistake. Okay, so voluntary response samples are a good way to have bias in your sample. All right, a sampling frame. This is a list of all individuals. Hopefully this is available. It's not always available. And usually at this point, and this is one of the sad things, this is one of my favorite things to do when we're in class. I'm gonna just have to show you, we're basically almost done with this. I'm gonna do one more thing. We're gonna finish at 1.4, but I'm gonna try to do an example of a random sample. Should I do it now? No, I think we're gonna cover 1.4 and then we'll do this. I'm gonna come back to a sampling frame and this, and we'll try to do a quick poll here in the class. Okay, so need to open up 1.4. Okay. Oops. Okay, we're going to talk about other sampling methods. Okay, so chapter 1.4 is other sampling methods. Okay, so we're going to talk about a stratified sample. So a random sample can miss out on certain segments of the population. So typically, like if you're talking about elections, blacks, poor women, or the homeless, you may, just because of the nature of the task, they're random, you might miss certain segments. And so to compensate, one thing you can do is you can divide your sampling frame into distinct groups. These are called strata. And then you take a simple random sample, SRS stands for simple random sample, within each strata. So you divide your population into blacks, poor, women, and homeless. And so then you will randomly sample within the blacks, within the poor, within the women, within the homeless, for example. And theoretically, this can give you a better representative sample. A stratified sample can be better than even a random sample. So this is another way to try to eliminate bias in your sample. So once again, it would be nice to do a census, but those can be costly. Now, another way to do, because I mentioned earlier, randomization can be hard. Now, let me just mention this really quickly. I'm going to go back to randomization. I had a class, by the way, has somebody left me a note? Okay. I had a class where there was a researcher from Seattle, and he had said that he was trying to find out if there was lead in your tuna fish can. And so he asked us, how would you randomly select a tuna fish can? And it was ridiculously much harder than I ever thought. Okay. So I'm going to throw this out at you. If you're going to do true randomization, one of the things that you would do is, so he lived in the state of Washington, so he randomly picked cities. Of course, you probably want to keep Seattle in there because that's a big town. So he had a list of all the cities in the state. So Seattle, Redmond, Spokane, I don't know what other, I should pick Utah because I don't know. So let's pretend it's Utah. So Ogden, Salt Lake, Provo, St. George, La Verkin, Spanish Fork, American Fork, Kaysville. There's a lot of cities in Utah. So basically, you'd come up with a list of all the cities in Utah, and then you would randomly pick a city, okay? Then you had to randomly pick a store. So where can you buy tuna fish? You can buy it at Walmart, Albertsons, Fresh Market, Skaggs Alpha Beta. You'd list all Target. You'd list all of the grocery stores in the state. So, okay, so maybe you'll randomly pick Kaysville, and then you'll randomly pick the grocery store Bowman's. Okay, so once you get to Bowman's, how do you randomly pick a can of tuna? Well, what kinds of tuna fish are there? You've got Chicken of the Sea, you've got Starkist, you've got Western Union brand, and you've got, or whatever, the store brand. So then you'd go and you'd randomly pick, Chicken of the Sea, let's say. Well, then you have tuna that's packed in oil and you've packed in water. So how do you pick? Well, you have a random number generator and you pick, so, you pick Kaysville at Bowman's, you pick Chicken of the Sea, and you randomly pick, it's packed in water, let's say. And so randomization can be very difficult. So one of the ways, maybe a simpler way, although not necessarily the best way, is to do what we call a systematic sample. And the idea with a systematic sample, you select every case individual. This can be useful, especially if you don't have a sampling frame of every individual. And so maybe you'll pick every third individual or every fifth individual. And so that can be an example of, you can think of this as kind of a pseudo-random way to do that. Another example of a sampling method is what we call a cluster sample. The idea is you select all the individuals within a randomly selected collection or group of individuals. So a lot of people mix up cluster with stratified. So here's the difference. With a cluster sample, let's say that I wanted to poll all of the English students, okay, at Utah Valley University. So with a cluster sample, what I would do is rather than pick people from every English class where so a stratified sample, maybe I would pick 5 people from every English class at Utah Valley University. So that would be an example of a stratified sample. Every class is represented and I've talked to somebody in every class. Whereas with a cluster sample, maybe let's say there's 40 sections of English at Utah Valley University. And so maybe I will randomly pick, say, 3 sections. So I'm not taking it from everybody, but in those 3 sections, I'm talking to every single person in all 3 of those sections, okay? And so each of those sections would be called a cluster, and I would be talking to every person in the cluster. And so that's an example of a cluster sample. So another example, a school administrator wants to learn the characteristics of students in an online class. Rather than obtaining a simple random sample, he could treat each class as a cluster and then obtain a simple random sample of the clusters. He then administers the survey to all students in the cluster. Okay. Another example of a cluster sample, a sociologist gathers data on household income in Boston. She breaks it up into city blocks and then randomly selects blocks and asks everyone in that block, what is your household income? So that would be another example of a cluster, okay? So probably a little easier way to collect data than, say, a stratified sample, but you're probably also going to be more subject to bias, okay? Convenience sample are easy to reach individuals. So you could go to the mall and ask people who's going to win the football game. We've already talked about the voluntary response sample. Multi-stage sampling is a combination of previous methods mentioned. So you can combine some of those things. Your sample size, obviously you want the largest sample size possible. This will help reduce bias. However, it must be balanced against cost, okay? So basically what I've done here is I've kind of given you guys all of these different sampling techniques. Now, here's what I would like to do. Okay, so what I want to do, and we've only got about 7 minutes left, but the idea here is I'm going to read off your names. Normally I'd pick on you in class, but we'll do this in class. Okay, so I'm going to read off your names. And so Alejandra is, so remember your number. Alejandra is number 1, Alexander is number 2, Anna is number 3, Broderick is number 4, Christian is number 5, Denton is number 6, Emily is number 7, Hayden is number 8, Jed is number 9, Jennifer is number 10, Jonathan is number 11, Caitlin is number 12, Keaton is number 13, Kylie is number 14, Marin is number 15, Matthew is 16, McKay is 17, Mia is 18, Neo is 19, Paul is 20, Rayleigh is 21, Sarah is 22, Tate is 23, Victor's 24, and Zach is 25. I thought it said we had 27. Well, I guess I didn't count myself. Somebody, anyway. Okay, so remember your number. Now, in the back of your book, oh, actually, let me show you this. In the back of your book, and if you don't have a book, you can also go to the announcements. I posted this already. We've got this thing called the book tables. So these are the formulas and tables that you're going to be able to use on all tests and quizzes, okay? Now, I would ask that you don't write on these, but if you want to print these out, especially if you don't have a book, you're definitely going to want to print these out. But these are all the formulas and tables we're going to be using for the entire semester. And as we go through here to the back, okay, so I've got random numbers, okay? Now I'll make this a little bit bigger, okay? So these are just a bunch of random digits. So this is a random number table, okay? Now let's say that I'm going, so we've got 26 people in the class. I must have missed somebody, but anyway. So let's say that I'm using line 7, okay? Now we've got 26 people in the class, and so 26 is a 2-digit number, and so I'm going to go every 2 digits. So I'm going to go every 2 digits. So 59, okay, we don't have a 59 in the class, so I'll skip it. 76, I don't have a 76. We're going to go to 15, okay? So 15, who is number 15? Say your name.
Marin.
Marin is number 15. Okay, so we're going to do a quick poll here, and this is going to be a simple random sample. And I'm going to add, we're going to do a quick poll. Do you want Biden or Trump to win the election? And so Marin, what do you say?
Not Trump.
Not Trump, so I guess that's a Biden. Okay, so I got 1 here for Biden. Okay, so now going back to my table, I'm going to go to the next number, which is 52. I'm going to skip that number. Then I'm going to go to 12. Who's number 12? Say your name.
Caitlin.
Caitlin. Who do you want to win the election?
Trump.
Trump. Okay. So we got 1 and 1. Okay. So now, let's see. We're going to go to the next number here. Sorry, I got too many windows open. So that was number 12. 33. We don't have a 33. We'll skip it. 36. We don't have a 36. 06. Who's number 06?
I'm number 6.
What's your name?
Denton.
Denton. Who do you want to win the election?
Probably Trump.
Trump, okay. So Trump, now notice I'm not campaigning here. Then we'll go to 87. We'll pick one more person. 51, 86, 73, 77, 97, 43, 85, 26. Who's number 26?
I think we only went up to 25.
Oh, we did? Okay. I must have missed somebody then. 23. Who's number 23?
I am Tate.
Tate. So Tate, who do you want?
Trump.
You want Trump? Okay. All right. So, okay. So the idea here is I've just done a thing. We got 3 Trump voters. So that shows that 75% want Trump and 25% want Biden. Okay. So that's how you would do it. And if you need to keep going, you'll keep going on to the next line. So you will have you will definitely have some homework on here. Now, one of the other things that I could do here, so that's a simple random sample. Now, another thing that I could do here is I could do a stratified sample. Now, the easiest thing for me to do is maybe I could do stratified men and women. So let me count the number of women we got here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know if Neo, Neo, are you a man or a woman?
A man.
A man, okay, 10, 11. Okay, so we've got 11 women, and that would mean we'd have 15 men, okay? Now so I've got 11 women, and I've got 15 men. So one thing I could do is I could do a stratified sample, where I could pick randomly let's see, 11, 15. Let's say I pick two random women, and I pick I pick 3 random men. And I could do the same thing, and I could, maybe we'll have a group of 5. And theoretically, that would be more representative of the gender difference in this class. And so that would be one thing. Another thing I can do would be a cluster sample, which would be to ask everybody in the class. We'll assume that our class is the cluster. Another thing that I could do is a convenience sample. And so maybe if I picked, go ahead.
Did you do more men than women for that sample because there was more men in the class?
That's correct. That's exactly right. Another thing I could do is maybe I could pick the first 4 people, Alejandra, Alexander, Anna, and Broderick, because you guys are conveniently next to each other in my list. So that would be an example of a convenience sample, okay? So anyway, I just wanted to give kind of a quick example of that. And so those are the different types of sampling techniques. So on your homework, the quiz tomorrow is going to be 1.2 through 1.2, 1.3, 1.4. Your homework will be all 3 of those sections. I've already posted it, but I'll post it again for today's for tomorrow's homework. I know I need to let you guys go. So any last questions before I let you go? Okay. All right. Well, thanks for coming today, and I'll see you all tomorrow, and good luck on the homework and the quiz.
Thank you.
Yep.
Thank you.
Thank you.
Thank you.
You're welcome.
I have a quick question.